Olaoluwa, who will be presenting, and his session is going to be on the proof of history, exploring Solana's cryptographic clock. So please, Olaoluwa, the stage is yours, and feel free whenever you're ready.
Hello.
Hello.
Good afternoon, everyone. So good evening. It's evening in Nigeria, yeah. So, okay. Today I'll be sharing with us I would like to share my screen. I don't know if I can.
Yeah, absolutely.
Okay. Okay, can anyone see my screen?
All set.
Okay, fantastic. Okay, so today we'll be looking at proof of history, exploring Solana's cryptographic clock. So I'll be coming from more of a simplified perspective, so I don't go into so many terms and a lot of stuff like that. So let's look at it now. Can proof of history be the consensus of the future? And surely the greatest irony in the blockchain space is that there has never been any agreement on the best consensus model. Today, we would explore Solana's unique advantage, leveraging the proof of work. Now, Solana has been the world's first web-scale blockchain, and the Bitcoin and the Ethereum though they are widely laudable from being that they are the pioneers of the concept of blockchain and smart contract platform, respectively. But both of them are heavily under criticism for lack of scalability. And prior to Solana, the blockchain has actually been criticized for being limited in terms of scalability. And when we talk about scalability, what do we mean? So now, the major blockchain scalability issues, I'll be exploring three major ones. We are looking at the block size, the response time, and also high fees. So these are three major scalability issues we'll be dealing with this very day. Now, let's talk about the block size. Now, what does block size mean and why is it important? Now, a block size is the amount of data that is stored in a block, needing to be validated before it can be accepted by the network. The number of transactions has increased in the network, slowing down transaction process, which can be time consuming. So now we see that as adoption increase and a lot of persons get involved in the network, then the volume of data keeps increasing. But then can the block size of each of these blockchain, either Bitcoin, blockchain, can it actually take so much volume and also process them at high speed? But because of the issue of scalability, now the more the volume congested, the more the volume of transactions congested in a block, it slows down the network process, thereby consuming time and creating a slow process before each block is being validated. Now, why is it that? Because in the previous blockchain, the issue with scalability, which comes with other proof of work and proof of stake, which is the consensus mechanism used by Bitcoin, that's proof of work, and the consensus mechanism used by Ethereum, which is also proof of work. Now, this has to do with some set of validators, some set of miners. They then come to solve. Oh, sorry, please. So some set of miners, they then come to solve some issues. Sorry, can you hear me?
you're all clear.
Okay, great. So some set of miners, they then come to solve some computer problems. Now, it is when the first person to solve that computer problem would be the one to validate the transaction. So different miners would now start solving a particular problem. In the process of solving a particular problem, it's time consuming. So therefore, this has also is an impediment on scalability on the blockchain. The next one we look at the response time. Given the large volume of transactions that is processed or that needs to be validated. Now, in terms of the number of transactions standing on the queue, they usually have to wait too long for their validation. So one transaction has to wait for another transaction to get validated, which means a transaction cannot get validated before another transaction. So it's a queuing process. And because of the large volume of transactions that occur daily, this creates a slow process in the transaction process on the blockchain. Now, and this is an issue, one of the major issues with scalability. Now, we talk about high fees. As the popularity of cryptocurrency grows day by day, the process of confirming transactions becomes more complex because mining demands higher computational power. And because of that, you have to pay more. Like every payment demands transaction fee. Now, we could practically, for many of us who have been involved with transacting,
Seems to be frozen briefly. See if he reconnects here in a second. Is anyone able to also let me know in the chat if anyone can hear him clearly? Yes, it appeared to have disconnected. Oh, and you're back. You're just muted right now, so yes, feel free to continue. Thank you.
all right. So now I was saying that high fees are one of those issues that has created limitations in the blockchain and also affected scalability. Now, how is Solana playing a different game? How is Solana playing a different game? Now, how Solana is solving the problem of scalability. Solana has emerged as to set the pace. The blockchain project is developing a secured, scalable blockchain that can handle up to 50,000 transactions per second on its testnet, which means in a second, 50,000 transactions are being processed. The last time I checked on Bitcoin, just 7 transactions to 10 transactions per second. Now you could see the difference, the speed, and the volume at which it could take in a second. Now, how does Solana achieve this? The core innovation that underlies the Solana's network is what is called the proof of history. Now, the proof of history is not a consensus mechanism in itself. However, it is a cryptographic clock in which we'll be exploring further in the presentation. Now, as the name implies, proof of history is a proof of historical record of events. Now, the proof of history creates an historical record that an event has taken place at a specific time and at a specific moment. Now, this is to say that as regards other blockchain, where one transaction would have to wait, for the miner or the validator to confirm if that transaction truly takes place before validating that transaction. Now, it's a different case on the Solana's network, right? Now, with proof of history, it tracks the time and the specific moment these transactions takes place. So instead of validators interacting with themselves, it is the time that interacts with themselves. So the time has already been programmed into the blockchain. Now, each validator or each validator don't need to have to interact to get this transaction approved. So because a time has already been attached to it. Now, let me give an illustration. If I take a picture and I put it on the newspaper, right? Now, if the newspaper publish my picture on their newspaper, it shows that the newspaper has been in existence before I took the picture. So it's more like a timestamp. So I'm trying to pass a message across that this picture was taken after this newspaper, was established. I don't know if you get my point clear. So now that is a proof of history that something had occurred before another event occurred. So proof of history shows it shows the record when transaction takes place and the specific moment transactions has taken place. Now, Solana's innovative proof of history is a cryptographic clock. Now, let me explain with this graph. I want to take my okay. Now, Solana's innovative proof of history is a cryptographic clock which allows nodes to agree on the time and order of events without having to talk to each other. Now, for persons who might not know what a knob is, knobs are participants in the network. Validators, they are also part of the knobs. Now, the cryptographic clock now, it allows the knob to agree on the time and the order of an event without having to interact with one another. Now, the time is encrypted by the cryptographic function, which decreases the knob's messaging overhead and computation, allowing the blockchain to reach a high speed. Now, what does that mean now? So now, in this cryptographic clock now, as an analogy that we're using here, is that without validators interacting with themselves, now the time they've already agreed on the time and the event. So they've approved that, okay, if this transaction carries a time and a specific event that has an historical record, this transaction should be approved. So it's like an encryptment already into the blockchain network. So there will be no need for knobs to start interacting with themselves before a transaction is being approved. Unlike other blockchain where one validator would have to interact with another validator, or one validator will have to solve a computer problem before validating a block. Now, in the ancient times, this is what they use for to track time. It's called a cryptographic clock. So now it shows the amount of time you've actually spent. So imagine each of us in this room now, we pour a water into this cryptographic clock that we want to spend some time to read, right? Now, we now track that from number 1 is 1 minute. So if it gets to this, if the water moves from this place to this place, it shows that we've spent 1 minute already. Now, if the water moves from 1 to 2, once it's dropping, it moves from 1 to 2, it shows that we spent 2 minutes. Now, when it moves from 2 to 3, it shows that we spent 3 minutes. When it moves from 3 to 4, it shows that we spent 4 minutes. Now, if you observe that this cryptographic clock is able to help us to keep a track record of the amount of time that has been spent and the specific time, right? So we now know that for 1 minute to be exhausted, the water would have to drop below to this level. Now, for 2 minutes to be exhausted, the water would have to drop below to this level. So this has already created an historical record. So if the water drops to this level 8, we already know that, oh, we spent 8 minutes, carrying out any activity we are doing. Now, that is the same thing which is being replicated in the Solana's blockchain, which is the proof of history. I don't know if you're following me, right? Are you following me?
Yes, very much so.
Okay, great.
It's spectacular.
So, come in. Trying to see if I could. Okay, sorry. All right. So now, if we see that this proof of history, the ability of the blockchain to interact without the need of a knob or a validator to interact actually speeds up the process at which transactions are carried out. Right? It speeds up the process as transactions are carried out. Now, the next one, although other blockchains require validators to talk to one another in order to agree on time. But while doing this, time passes. Now, each Solana validator maintains its own clock by encoding the passage of time in a simple sequential hashing verifiable delayed function. So this is a function that is actually the clock time is being encoded into the blockchain, right? So now validators wouldn't have to wait to actually interact, but they would only have to agree on a time. So once time shows that once the time of the transaction that is being carried out is as an historical record already on the chain, the transaction is approved without delay, right? And this makes the difference in the Solana's blockchain. Now, this takes exception from the prevailing standard of blockchain infrastructures, which relies on constant production of blocks that are hindered by waiting for confirmation across the network before moving forward. Proof of history presents a fundamental move forward in the structure of the blockchain network in regards to speed and capacity. When transactions takes place, it is recorded in real time. It is easy to tell what event happened before another. So it's so easy to tell what event happened before another. So as the 50,000 transactions are coming into the block, now it is being validated when it shows a proof of history. Don't forget I said that the network has already had time encoded into it. So now that time comes in agreement, right? Already. And then the knobs, which are the validators, already would have agreed that, okay, if the time shows a proof of history that this event has occurred, this transaction has occurred, it should be approved. So that is what it is now. Now, and this is different from other blockchain infrastructures. Now, why is Solana trying to move? Okay. Now, Solana is the world's first web scale blockchain. And here is a very obvious comparison. Now, when we compare the Solana network with the Ethereum blockchain network, with Binance Smart Contract, with Polkadot, with Cardano, and with Tron. Now, transactions per second on Solana is 65,000. Now, which means a transaction per second, 65,000 transactions, is being executed per seconds on Solana's network, while Ethereum can only do 15 as at the time this record was being taken. 15. Now, Binance smart contract can only process 100 transactions per second. The Polkadot, blockchain can only process 1,000 transactions per second. The Cardano blockchain can only process 270 transactions per second, and Tron can only process 1,000 transactions per second. Now, compared to the volume of what Solana can do, this is made possible by proof of history. Don't forget, each of these other blockchain are either proof of work or proof of stake that needs validators. For proof of stake, needs validators to come in agreement before a block can be created, before a transaction can be executed. Now, for the proof of work, miners would have to solve a mathematical problem before a block can be created. So a lot of miners start solving a problem when a transaction is taking place. When transaction occurs, the blockchain receives the transaction, then the miners would now start working on solving a mathematical problem. Now, the first person to solve that problem gets rewarded. Now, imagine the number of time you'd have to wait. So now it can only take 15 transactions per second. Now, let's talk about the average fee per transaction. So if I am sending, mind me please, excuse me please. If I'm sending Solana, I will be spending an average of $0.0015, which is even lesser, more lesser than a cent. Now, if I'm sending Ethereum, I'll be spending, I'll be charged $15 or more per transaction on average. Now, if I'm sending Binance, I'll be charged less than $1, which is 0.01001. Then on Cardano, I'll be charged $1 for average fee per transaction. Then on Polkadot, $1 per transaction. Then on Cardano, I'll be charged $0.25, right? Then for Tron, it's free.
Oh no!
Now, if you look at that, there's a condition that comes with Tron. Now, a transaction. You said?
Apologies, you just cut out briefly, but you're good to go.
Okay. Now, the number of validators are 702 validators. Okay. Now, this shows the uniqueness, which is one of the key innovation and one of those things that has actually brought a solution or providing a solution to
Would you be able to go over just the last 30 seconds? Again, you just cut out briefly, and just to touch up on your final slide there, if that would be all right.
Okay. Thank you very much.
Thank you.
Okay, so I would just want to go over this area again where I said, how does Solana achieve this? So now let me start from, okay. Now, don't forget I said the major problem in the of scalability issues are the block size, the response time, and the I fee. So from what I've previously explained, you will discover that now the block size the problem of scalability is that the larger the volume of transaction coming into a block and having to wait on a queue for the previous transaction to be executed and approved before the next one is being approved, would create congestion in the blockchain, thereby slowing down the network process. Now, when we talk about response to time, we are looking at how fast is transaction being executed. How fast is transaction being executed? And because each transaction would have to wait for the previous one to be approved, and then each validator would have to agree before an approval can be made. This creates delay, which is one of the problems affecting scalability, blockchain scalability, the response time. Then the high fee, we discovered that in prior to Solana's proof of history, we saw that Ethereum has a very high gas fee, high transaction fee. Bitcoin has a very high transaction fee, which also is a limitation. Because so imagine you want to send a $100 worth of Ether, to another person, and then you are being charged $15. That costs more, which means you are paying so much, because of the congestion on the network. So which means the higher the congestion on the network, the higher the gas fee, right? Now, why are they charging higher for the gas fee? So that when you pay higher, you can be quickly validated. So this is creating congestion in the blockchain. Now, then Solana came up with a proof of history that, okay, why should a validator have to interact with one another before, having to approve a transaction? Or why should a miner have to take miners have to take their time in solving a mathematical problem before a transaction can be approved? This would create a delay in response time, and when the demand on the network is high, the fee increases. Now, Solana came up with a solution, which is the proof of history, like I've explained earlier, right? And then this proof of history has to do with time. It only has to track time, which is, I don't know many of us who are familiar with timestamp. So when a particular commodity is being released and it's a time and date is being written on it, it's more like showing an approval, an historical record that this was done at this particular time. This commodity was produced at this particular time. This picture was taken at this particular time. And I remember I read somewhere that in the era where there was no technology, when scholars write their materials, so when they come up with a law or they come up with a discovery, now they will put a timestamp on it. Now, when they put a timestamp on it, nobody can come and say, this is my work, and this is when I released it. That timestamp is a proof on its own that this was released at this particular time, at this particular event. Now, Solana leveraging on proof of history now. So now the validators would not have to wait to interact with one another, but will only have to agree on the time. So if the time that a transaction takes place is as an historical record, is recorded already on the blockchain, the transaction is approved. So it doesn't have to wait for the previous one. No transaction has to wait for another, right? So they are being approved based on time. And that is why the transaction is very, very fast, which is one of the solutions to the problem of blockchain scalability. Okay. So I don't know if that's all, or you want me to still
Yeah, that was extremely clear. And I also want to thank you for your vibrant illustrations of the context, because it really makes sense now with this cryptographic clock and how it's measuring the time and how it's solving the scalability issue, at least to an extent. So I also wanted to say that your last slide there was very well received, the chart outlining the benefits and also the shortcomings of the different systems, and really allows people to make the decision for themselves which ecosystem that they can see themselves playing in for the most part. But yes, thank you so much. If there are any questions, we're not diving into another session right now. It's more so just a networking session. So there is time to further ask any questions. And there is one here from Sahabe who says, would you explain the last table, please? And even especially just the latter end of it as we were cut off there.
Okay, this table?
Yes, correct. Thank you.
Okay. Now, so on this table now, I said Solana being the world's first web scale blockchain. Now, what we are trying to compare in this place is to balance up the volume of transaction that Solana's blockchain handles per second, executes per second, compared to other blockchain. Now, and also the average fee. So what would I be charged if I'm sending Ethereum? What would I be charged if I'm sending Solana? What would I be charged if I'm sending Polkadot? Now, we're also looking at the numbers of validators. Now, on Solana, we see that the transaction per second is 65,000. Now, which is the network can take 65,000 transactions per second, right? But Ethereum can only take 15 transactions per second, right? Then the Binance Smart Chain can only take 100 transactions per second. Then the Polkadot can only take 1,000 transactions per second. Cardano can only take 270 transactions per second, and Tron can only take 1,000 transactions per second. Now, if you are transacting if you're interacting with the Solana network, now you would only be charged $0.0015 per transaction. But on the Ethereum blockchain, you'll be charged $15 or more, right? Now, on the Binance Smart Chain, you'll be charged $0.01. Then on the Polkadot Smart Chain, you'll be charged $1. On the Cardano Smart Chain, you'll be charged 0.25 cents. And on Tron, you wouldn't be charged for anything. Now, when you look at the top leading blockchain, you will see that Solana has been able to, number one, capture a larger volume of transaction per second, which is, I would say, almost 1,000x of what some other blockchain can do. Now, the average fee is also, ridiculously cheap. Now, we'll also look at the transaction latency. Now, when we talk about the transaction latency, it's talking about how the transaction is being carried out. Now, on Solana's network, a transaction will only spend 0.4 seconds. 0.4 seconds. Now, but on the Ethereum network, it will spend 5 minutes. Now, you want to know how many seconds you will see in 5 minutes. So which means you would have either sent and received Solana much faster at a cheaper rate, right, for transaction fee than you will on the Ethereum network, where you would have to spend 5 minutes, on the transaction latency. Now, on the Binance Smart Chain is 75 seconds. 75 seconds is 1 minute and 15 seconds. Then on the Polkadot chain, you have to spend 2 minutes for the transaction latency. Now, on the Cardano, you have to spend 10 minutes on the transaction latency. And on Tron, you spend 3 seconds. But compared to what you would spend on Solana, you would spend 0.4. Now, you would see that this has actually solved a large problem in scalability, which is the response time. Now, the number of validators on Solana is 702. Now, we're expecting more validators as the network expands. It's a growing network. It just came up, and though it has been in existence for a while, but I think it was launched. It has been in existence in 2018, and it was launched in 2020. But then And so it has so much potentials. Then the total transaction date to date, that is the particular date this data was taken, is 15 billion for total transaction. Then on Ethereum is 1.07 billion. Can you see that? It is very, very different. The difference is clear. Then on the Binance Smart Chain is 227 million. The total transaction that has already been taken as at the time this data was compiled. Now, on Polkadot is 1.7 million. On Cardano is 5.9 million. On Tron is 1.7 billion. Now, but you see that, which means so many transactions are coming into the Solana network, and that's because of the leverage on that. The leverage that what's it called? Proof of history has actually created. The solution to scalability, the solution to the response time, delayed response time, is no more there. Then the block size, it takes a larger volume and processes it at a very fast pace. So this is one of the first web scale blockchain right now.
Thank you. We do have a couple questions here, one from Simon, one from Hannah. And Simon says, what is the difference in cost by machine between Solana validators and the others?
What's the what?
What is the difference in cost by machine between Solana validators and then the others?
Okay, now the difference in cost is quite clear, and that's on this table. You can see it here. Now, so it would cost you less than $1, which is even less than a cent, to actually transact on the Solana network. And it will cost you $15 to transact, $15 and more to transact on the Ethereum network. I don't know if that's clear.
Yeah, it makes sense when looking at the exclusive blockchains themselves and what their particular transaction fee is. I hope that answers your question, Simon, just in terms of the differentiation of them. But the last note here is just clarification on, is this a consensus protocol, or that it is not a consensus protocol, correct?
Okay, so it is not a consensus protocol.
Yeah.
Right? It is a clock before consensus. That's how we call it, the cryptographic clock. Now, so the Solana network interface uses the proof of stake and in conjunction with the proof of history, right? So now it uses the proof of history to solve the problem of speed and low transaction fee, right? And also uses the proof of stake to actually secure the network, right? So now if a validator, who must have a huge stake in the network, decides to approve a transaction that a transaction that is not supposed to be approved, or wants to mess up with the network. Now, with the proof of stake, now the consensus mechanism has a way of dealing with bad actors who wants to cheat on the network. Don't forget, it's a trustless network, right? So you are not trusting the next person beside you. You are only trusting the network. And because the network has a way of dealing with bad actors in terms of slashing their stake. So imagine if I'm a validator and I decide to try to cheat the network can punish me by taking 50% of my stake. So I wouldn't want to do that, right? My money is at stake. That's how they call it, stake. So each validator is just so that to secure the network, right? And to make it trustless as it should be. So it's, in a way, by using proof of stake, we are trying to make sure that Solana is still operating a decentralized system and not a centralized system. So proof of history on its own is not sufficient enough, right, to create all these exploits. But with the help of proof of stake, it creates security and also maintains the network as decentralized, right? But with the proof of history, it helps to solve the problem of scalability, like the three major problems in which I've outlined. I don't know if I'm clear, if we are clear with that.
Yes, your explanation is definitely being thanked. We do have other questions here, such as how Solana can prevent an attack, such as a 51% attack or something of the liking.
Okay, come again, please.
How do you think that Solana would be able to prevent an attack? You know, the common example, if you have 51% or more of the system, then you can overwrite the blockchain. So is there another protocol in place or something to prevent that specifically for Solana?
Yes, that's why I said it uses the proof of stake and the proof of history. So how does it prevent the network from being attacked, right, by bad actors? So it prevents the network from being attacked by bad actors by punishing bad actors, right? So each person who are validators on the blockchain, knowing that if they try to cheat the network, they will be punished for it. I don't know if you get my point now. They will be punished for it. Punished in a way in different ways, but one of the ones I'm familiar with is by slashing their stake, and also by any percent. So it might be 90%, it might be 80%, depending on the gravity of the offense. So this would help to maintain security, and I'll be able to trust the network. I'm not trusting the next person. So the blockchain technology now is like I can interact with bigger transactions of cash, of money with you. I'm not trusting you because you are on the blockchain. I'm trusting the network to be able to prevent me from being cheated by you, right? So
yeah, so people are definitely not incentivized to cheat the system because there are definitely repercussions there. Okay. Makes sense. And then additionally here from Anchor, he says, could you give an example of some bad actors that do happen on the network, or at least can?
Okay, now like approving a transaction for another purpose, like for a wrong purpose. Now, in more or less like if I'm a validator, right? I want to cheat the network by siphoning money to my own account, right? Now, don't forget that it already has what's it? They call it a hash code, right? An hash. Now, that hash is a unique number that is on every transaction, on every block. Now, so if that unique number is not interacting with the right block, if it's being like I'm trying to divert the transaction, right? So once the network discovers, how would the network discover? The network would discover because there would be a disagreement between the data contained in the previous block and the data contained in the new block. Don't forget, for every transaction that is being carried out, the previous transaction is embedded in each other. I don't know if you get that. Previous transaction is embedded in each other in a form of code, right? So each of those transactions are in one another. So that's how you call it a chain. So if they are not agreeing, then the network will spot the person as a cheater, the validator as a cheater, and therefore punish him or her.
Because it'll always be traced back
Exactly.
on the same link. Yeah.
Definitely.
Okay. And here Sahabe also says and asks, how by proof of history does Solana trust the nodes? Is it due to the SHA or other cryptographic algorithms?
Okay, now that's why we said the proof of history on its own, right? I don't know if I get that question very well. Just come again. I want to be sure I'm not mixing it up.
Yes, I hope I'm not mixing it up either, but however, it's stated as how by proof of history Solana can they trust the nodes?
Okay, now if they can trust the nodes, of course, but then there are other how do I put it now? You know, innovation, technology that is being embedded into the network, right? So aside from proof of history, like I said, there is proof of stake. Now, this helps to create a balance in the blockchain network.
Mm-hmm.
Yeah.
Okay, and as a follow-up, so the proof of history means that they passed the SHA?
Exactly.
Okay, lovely. And yes, Olaoluwa, thank you so much for extending your time here more than you even registered for. It's really much appreciated. And I saw a comment earlier from Belinda, I believe, who noted that you speak with such passion and that really emanates from your presentation. And I can definitely attest to that. I feel it as well. It's very palpable. Thank you so much for your time. If there are any other any links that you could forward to us that you could throw in the chat, that would be much appreciated. But this was all more than enough. And for anyone else, if they have questions, always feel free. You know you can do so. I will be placing everyone into breakout rooms now just for the final 10 or so minutes here before our next session coming up. So thank you so much for your participation, and let's have fun. Let's embrace it all.
Thank you.
Thank you.